Okay guys, this is engineering drawing N2. This is engineering drawing N2. So the question read as follows: draw to a scale 1:1 the given front view of a socket head bolt. This is the socket head bolt. Provide the length 90mm of the shaft with a single star external right hand V screw thread. So we are drawing a single star external right hand V screw thread. So the pitch of those threads, they are expected to be drawn by using 5mm. Draw the screw thread in horizontal position. So show all hidden details. So we have to show all the hidden details of this one. So line work, accuracy, layout and neatness also count. So after that one, okay, isometric. So the very first thing that we are going to do, we are going to draw this given view the way as it is, and then we are being asked to provide a V screw thread right-handed external where they mark a length of 90mm from here till there. You understand? So V screw thread. So let us draw it. So the very first thing that we're gonna do, we are going to say 64 divided by 2. Amarcha, you getting 64 divided by 2, so that you get the radius is 32. So I will take my drawing compass, open it to 32. I place it at 0. There's 30, 31, 32 is right here. You understand? So I come and let me put it somewhere here, and I can draw this one. 32 is diameter 64 divided by 2. We are getting 32. We are open a drawing compass to 32mm, isn't it? So this is this one. So from there we're supposed to draw. From there we have to draw the hexagon that is across the flat. And we are told that the height or the length from here till here is not the height, because it's not going vertical. It's supposed to be 32. So I am going to open my drawing compass. Or before that, where I was placing my drawing compass here, let me draw a vertical center line. And a horizontal one. So which is this one? There it is, and there it is. Understand? So then I want to draw a hexagon that is across the flat, and from here till here I have to get 36. So I am going to open my drawing compass to 18mm. 18mm, there is 19. So I draw a faint circle. It has to be very faint, because it's part of your constructional line. And then on the vertical component, now I can place my drawing compass here, and I strike an arc here, and I come and strike an arc here. Even on the bottom part, place it here, further extend to the center, I strike an arc here, and I strike an arc there. Then from there I can have this one now, solid there, solid right here, There you go. There you go. Here we go. There we go. Then we are told to go from here till there is 32 millimeter. Let us check. Is it 32 millimeter? 30, 31, 32. So it's correct. 30, 31, 32 millimeter. You understand? So we open our drawing compass to 18 millimeter. We drew this cycle first here. So then we place our compass here, further extend to the center, striking arc here, striking arc here. We place it here, open it to the center, striking arc here, striking arc here. So you get your hexagon that is across the flat. All together. Then from here till the, because this is a right view. Remember, this is given in third angle orthographic projection. This is the third angle orthographic projection symbol. So which means this is the front, this is the right view. So we have to observe the orthographic projection law. So now from here till there, I am going to measure 20 millimeter. And I have a vertical center line. And this one. And this one. So there is no need even for me to further extend it this much, because I know OT, I am just looking for a dimension of 40 millimeter. So from here till there, 40 millimeter, which is this one, isn't it? If so, where is your 40? This is it. After your 40, there is a 90 millimeter. So where your 40 ends, I can put the horizontal, vertical centering. Then from there, there is a 30. From here till here, 30 millimeter. There is my 30 millimeter. So remember the scale, they said 1:1. There is my 30 millimeter ending. Then after that, I can record the 90 millimeter. So yes, my 90 is ending here. From there till there is 90 millimeter. So I will draw the vertical center line. So from here till there is 40 millimeter. From here till here is 30. From here till here is 90 millimeter. So now, what is the what to call the thickness of the shaft? Actually is 32 millimeter, diameter 32. So we are going to say 32. I think it's 1632 divided by 2. You must have your calculator by your side each and every time, isn't it? So I come now here to have put it like this. There's my 16 millimeter. It's this one. So I mark it 0 and I mark it 32. There is our 32. So now I can have a projectional line or horizontal constructional line like this. So from here till there is that 90 millimeter, which they said we must put a thread, a V screw thread. So what is left now? Let's have this one solid. You understand? So I'll have this one solid without favor. This one, there it goes. There it goes. Like this we go. Then let me remember the set show all the hidden details, isn't it? So what we see here, this we have to show it, you understand. So I will just have this as constructional line. There it goes, even this one. There it goes, this one. There it goes, this one. Right. So now we are given the angle 120 from here till here, you understand. So we are going to use our protractor. So before we even do that, let's put the thread there now. So they set a V screw thread with the right hand external, so which means what we supposed to have in our mind is that our thread, they must land on the opposite of this weight, which is left, since it's external, you understand. So our thread, they will slant on the opposite of this weight, right? So which means our thread, they must land this position. Since we are drawing a V external, V external, right? So we are going to start with a 0.5 times pitch, and the pitch that we are given is what is 5 millimeter. So we are going to say 0.5 times pitch, which means 0.5 times 5 millimeter. So you are going to get a half pitch, which is 2.5 millimeter. So this 2.5 millimeter, it is the one that you are going to start with right from this bottom left hand corner of your shaft, you understand. So the half of 5 is 2.5, so I am going to say 0, isn't it? 1, 2.5. The 2.5, 0, 1, 2.5. So the 2.5 is between 2 and the 3, isn't it? So there is our 2.5, you understand. So from there I am going to say pitch, which means full pitch. After the 0.5 times pitch, you are going to say now full pitch, which means it's 5 millimeter, 5 up until at the end, you understand. So we started with the what? With half pitch. So if you want your thread to be slanting on the right position, which means the question was going to say draw a what? An external V screw thread position left, which means now your thread, they will slant in right, which means what we did here, you are going to do it up there, you understand. So now we want our thread to slant on the opposite of this weight, because this is an external V screw thread, so they must land on your left hand side. Okay, you're going to see. So now since I'm going to say pitch, I can easily take my divider or my drawing compass and open it to 5 millimeter, which is this. Now I can say 5 A1 up until at the end. Can do it with your divider or your so our last 5 millimeter is actually right there. So now what we are going to do up there, you are going to start with the full pitch. So you start pitch, so it's full pitch upside. There you go. You can do it with your divider or your drawing compass. So I prefer you do it like this. So like this. Then after you are here, so what can you do? So now I am going to take my 30 millimeter ruler. This is the first point, this is the first point, isn't it? This is the second, this is the second. This is this 30, this is the 30. So I am going to join the second point on the bottom part with the what? With the first point up there. So this is the first, this is the second, this is the first, this is the second. So I am joining the second point. Thereby you have pitch, isn't it? So it's the second point with the first point there. Dark. There you go. Like this. A1. So I've joined the second point with the first point. Now join the third point with the what? With the second point. There you go. You do the same thing here. There you go. There you go. So you see that your thread they are slanting on the on your left hand side other than right. You understand? So there you go. So you can do them dark. There you go. Go. There you go. So now to draw the depth, we are going to use this type of a set square, isn't it? We are going to use angle 60 clockwise and anti-clockwise. So let's start like this. You understand? So I will firstly draw them faint, since I don't know how long going down are they going to be. You understand? So there you go. There you go. 60, isn't it? There you go. So it was 60 clockwise direction. So I am going to turn my set square like this now and have this one now dark till there. Now because of I know what is going to be dark till where, isn't it? So I can draw it dark once. There you go. There you go. You see the V shape is already coming out. You understand? So I can now come back to have it solid now. Solid now. Because I know what is solid from here till where. There you go. What you did up there, you can now do it down here. You understand? So it's up to you which one you start with. So I'll start like this faint. Firstly draw them faint. What you did up there, you can do it down here now. Remember your T-square is against your drawing board, isn't it? So it's supposed to be attached there. You have to keep on checking it now and then. And this set square, it has to run along your T-square so that you get perfect, correct, accurate angle. So there you go. Before the last one, there you go. So now I can twist it like this. So now I will even have it solid, because I know what is starting from here till there. So the V shape is coming now. Amen. So let me come back to have them dark now, because they were not dark before, because I didn't know what is starting dark from here till where. So that is why you firstly draw them faint, so now I can know what is dark from here till there, isn't it? So that is why I can draw it dark straight away now. So there you go, there you go. So now this one have it dark too. So now I can have a vertical line from here to there at the end, that one A1. So now I can take my 30mm ruler and I join the inner points now, which are these ones, this one with that one, this one with that one dark. There you go. This one with that one, there you go. You see, this one with that one, there you go. This one with this one, there you go. Solid, solid, solid. Then from here till right there. So this is it. So that's how you go about it. So we've drew the external right hand V screw thread, you understand? So if you check that this one there by your textbook, confirm it with you see they started with what, with the half pitch, and then from there pitch, you understand, and then up there they started with that one. So if you check they started with pitch. So if you check there by your step 2, they join the second point with the first one, the third point with the second one, of which is what we did here, you understand. And if you read it, this is the worked example, isn't it? So read the question was like the pitch was 4mm, so this M64 is to us is this one from there till there, to them is this one from here till there, you understand. So it was actually corresponding exactly with the worked example there in your textbook. So what external right hand V screw thread, you understand. So the length here, it was 60 to us, it was 90 from here till there, you understand. So at the end, check their solution. You see the thread that they were slanting opposite to this word, which they set right. So that's how we draw external square, not square, V screw thread all together. So now we can come to see what was happening here. So this angle 120, how do you get it? Have your protractor. If you don't have, it's a problem. Let's come back here. From here till there, the set is 40 millimeter. So this line is behaving at the center of 40, this one. So which means from there till the 20, from there till the 20, isn't it? So do it. There is your 20 millimeter. So it is not the center. I can only have a constructional line, you understand, and have these ones as a what, as a hidden detail. There you go. Right, to get this 120 degrees, we are told that use this one as a reference, the vertical center line as a reference, and we know what this line of yours is going to touch that corner, this one, this corner, so which is this one to us. So have your protractor. So I am going to place my protractor like this and flash it up until there is a 19, isn't it? 100, 110, 120, isn't it? So up until the 120, whereas this, the 0 is on top of your of your horizontal center line. Where is our 120? Is that one? Yes. So check, this is 90 degrees, isn't it? 100, 110, 120, isn't it? So, and when you check your 0, your reference, your 0 is at your reference, isn't it? And let me be accurate. Yes, there it is. So where is your 120? Is right here, so I can give it a mark there. So after I've gotten this mark of ours, take your 30 millimeter ruler now. I am going to join this point with that one, faint, but further extend it up until it touches my horizontal center line. So there it is. So which means otherwise I've already gotten this one from here till there. So I can now have it dark but hidden. You understand? So we've gotten it. What you did here, you can even do it up there. You understand? Even if you don't do it, for the fact that you understand from there till there, it will be the same. So you can only take your 30 millimeter ruler to join this point with that one. You understand? Let me repeat that. How did you got this? We are told what is at an angle of 120, isn't it? So have your protractor, because it's out of special angle, put it like this. And what do you know is that this line is passing that point of yours, isn't it? So going straight. So you are going to flash it, whereas your 0 is on top of your vertical, of your horizontal center line. There is your 0 is in 10, 30, blah blah, up until 290. So the point that the angle that you are looking for is 120. So do you see that is the point is right there? So which means I'll flash it back, up until at that. That is why we have to have a transparent protractor. So there is 120 passing that point that they set the line is passing. So I just mark at that 120, isn't it? You understand? And the 120, it is corresponding with what? With angle 60 degrees, which means if you understood that very well, you would have just used angle 60 degrees. How? Like this. You see? So the 120 is in the same line as 60 degrees, isn't it? That is why when you put your t-square like this and you put angle 60, it's still coming. Understand? So which means even this other side, I can get it with 60. There it goes. You see? It's absolutely correct. You see that is coming from there till there. You see? I can easily draw it with what? With my 60. So let's say you did not understood that. You would have used, that is why when I'm putting it at 120 like this, né? So they said your reference is starting from here, isn't it? Check very well. They said it's starting from here till there. So that is why your 0, it will be there. 0, blah, 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 90 up until to 120. The 120 that they spoke about. But you see now, you see that this 120 is at the same as what? 60. So that is why this is 60 anti-clockwise and clockwise. That is why when you put it like this, it's still coming. You understand? So now I can have this one is hidden. So thank you very much, guys. That was Mr. Nkosi for you. This is engineering drawing N2. See you on the next video. Okay, bye, donkey. Don't forget to subscribe and like and share the video, guys, so that we draw together. See you on the next video. Okay.